welcome to Unprofessional Engineering. My name is James.
And you got Luke.
Luke, we are joined by two special guests here today. Number one, Ethan Kurtz, captain of the Riptide Battlebots team, set to take over the world soon here on some upcoming episodes of Battlebots. And also our longtime friend here on the other side of the screen, Greg Paulson from Xometry. Greg, you are old news, but Ethan, thanks for joining us. No, I'm kidding, guys. It's great to have you both. It's really excited to talk to you here a bit about Battlebots, Xometry, and how you two are working together to, destroy other robots.
Thanks for having me, guys. So Battlebots is going to take place August 20th to the September 4th in Las Vegas. And so that's when we're going to start filming. So we're a week out, which means that we are not sleeping until we go.
I was going to say, does that explain the height of your hair and the untrimness of the beard because you're not sleeping much?
Yeah. Yeah. So currently the plan is to grind away at the robot and then at one point take a haircut break.
Nice.
And just get it all done at one point. So the beard will go.
You may not want to be on national television with that hair. You're okay for our podcast, but national television.
I like it.
This is the hair. It's the hair. Like I could see that. Like as the day goes on, usually at work, you keep on seeing emails, or you keep on having work done, and you put your hand up there. It just adds volume. I mean, it's just a true engineer. Just has high volume hair.
Especially think the hair makes you a fan favorite.
To be honest, I just want to be unique among you guys, since none of you guys have beards. I just wanted a way to differentiate myself.
I love it. Ethan, this is wonderful. Could you tell us a little bit about yourself and then maybe how you even got into Battlebots to begin with?
Oh man, that's a very long story. So
let's keep it kind of concise.
Okay, I'll be concise. So my name is Ethan Kurtz. I'm a mechanical engineering student at UC Riverside, and now I'm competing on Battlebots as the captain of Riptide. So how I kind of got into this is our team kind of originated from like the high school VEX robotics program. And then our goal was to actually kind of win that program and become, first in the world and whatnot. And then COVID hit. So there was a big change of plans in that area. And, that was really sad because we, thought something would go this way, but then everything got canceled, which really sucked. So after that, what kind of happened is, a lot of us tried online school, and it was really hard for us to focus because we're so used to in-person learning and hands-on kind of thing, and like working on CAD and stuff with like people, like that's how we learned. So online school wasn't like for a lot of us. And then we were like, all right, if we're not going to do online school and we can't do in-person school, what are we going to fill this 1 year time gap with? And I've always had this goal of doing Battlebots. Like, I've looked up to like a lot of my older friends have been doing it, and like people I know before that, and I've been watching it since I was a kid. I was like, and I always wanted to do it, but I didn't know when would be a good time. I was like, all right,
no better time than the present. Yeah.
It's just, I'm never going to have more time to work from home or undisturbed, just like, because there's a huge startup cost to getting into, like getting into and doing well at Battlebots. And at some point we would have to like conquer that hump if we want to stay. So we decided to do it now during COVID.
The best part of that whole story, Ethan, is when you said, when I was a kid, I used to watch Battlebots.
But that make you feel bad, Luke.
It did. It made me feel terrible. So are you a graduating senior? You have graduated. Did the year off delay it? Like where are you at education wise with wrapping things up?
Because of the beard, right? I look older than I actually am.
You do.
So I
distinguished.
Thank you. I just graduated high school. Man, how long has it been? Like a year ago? It's been too long in quarantine. I can't keep track of the days anymore. But yeah.
How did I not know you were a high schooler? I was thinking
you not anymore.
Well, not anymore, but that's how I not.
Yeah, I knew you. I knew you were thinking I was a college student. So I had to say I was a high schooler.
Yeah. No.
But
James and I always feel bad about ourselves when we see these really successful like high school and college students because we're like literally like 3 times your age in some cases, and here you are competing on BattleBots in Las Vegas in a week.
Yeah, hold on.
Give them a week.
Yeah, give me 2 weeks and then we'll come back.
I love it.
So yeah, I'm actually 20 now, so I'm not like quite young, but I'm not like old. Like, I don't know, I'm in this weird adult.
Watch what you say.
Young.
That's right.
Sorry. No, like, yeah, like insecure adult mode, you know?
I gotcha.
I mean, like just becoming adult, like trying to figure things out.
Making
it's weird. It's
robots
weird.
that destroy everything. That's great.
Yeah, we build robots that destroy everything. It's weird, like this coming of age thing, like where people rely on me.
It's the worst.
I'm not, yeah, I'm not used to getting relied on. It's quite a bit of stress and quite a bit of people like need me and want me to do things. So I'm like shooting from place to place and driving from place to place, and that's like quite a new phenomenon for me.
Yeah. So you mentioned this financial hurdle. So how did you guys overcome that one to even get started?
So sponsors, and networking. So thank you to Xometry for being our top sponsor, by the way. So they've been making around 80% of our robot parts. So we had to network with like a bunch of our sponsors. So like we have Xometry, Senkatsen, Max Amps, Rolling Robots, and others like Be Courageous. And we had to have like a bunch of sponsors to basically have enough money, have enough funding, and have people who could support us in our build. Like Xometry, like we need a part quickly, or if we just need like manufacturing help or anything, like we just go to Xometry. They get it done for us really quickly. They're really fast on their responses, for example. And the Fusion transfer is really easy. Like it's 10% off if you use Fusion and Xometry together, which is really, really cool.
Awesome.
I think I've had people...
And that's a few, just want to plug for that. That's the Fusion add-in that we added just, a few months ago for Xometry. So like that's actually in the Fusion App Store. So you're actually pricing right in the right while you're designing in Fusion 360, which is cool. And we're actually
totally slick.
We're eyeing for a V2 in the near future.
Oh, really? Wow.
Well, further but near, if you will.
It's been very helpful so far. Like in terms of just like figuring out what parts cost. And actually, I was asked recently, like what made you choose Xometry over like other online platforms? And it was like their speed, their professionality, and their discount on Fusion.
There you go.
So yeah, that app has been really, really helpful.
Awesome.
Can you tell us a little bit more about this? Because from your YouTube videos, what they've taught me is your name is Ethan Kurtz and you use Xometry to build your BattleBot. So I've watched quite a few of them, so I have this line down. But like you were saying, my understanding at least is you build something in Fusion, you're able to just like click a button, and like Greg was saying, not only are you able to then send the part from Fusion 360 over to Xometry or to the distributed manufacturing to have it be created for you, but it also tells you what's the price of one of these, 10 of these, 100 of these parts going to be. I'm not really good at stuff. Can you tell me how this magic works?
So, in Fusion, we basically, we take our part and we convert it to a component. And then there's just like, I could even share my screen if you guys want, but there's just like a little button and you go and it just and you click on it, click on your component, and it price checks it for you, and then it takes you to the website, and then it shows you how you could get it done. You could get it done locally, you could get it done internationally, you could get it done really, really fast if you are very, very desperate and want to pay a lot of money and you're on a 3-day deadline or something. So like we are. Which is perfect for us sometimes when we're forgot to order that part a little while ago, and then we realized, oh crap, we can't do this cheaply, and then we just do it like expedite because that's what we need in the moment. So it's basically how we do it, and I like how easy of a transition is. So like a lot of our parts aren't high tolerance parts; they just need to be within plus or minus 5 thou. Okay. So Xometry makes that really easy because we don't actually have to provide drawings or anything. We just need to provide the step file. So it's like we could go from making a part to and ordering the part is like 20% of that time. So it's like maybe an hour, like whole process from making to ordering.
Wow.
And it's like quite a crazy deal. And Xometry has really good prices, we found, like especially the international option. Like one of our parts, like our most prominent parts, is our weapon bar. And that, like compared, we price checked it with machinists and like against like actual real life stuff, like because we wanted to see like are we getting scammed. And so the weapon bars are 4140 alloy steel, and on Xometry we wanted to order 3 of them, so we price checked it in real life, and we were seeing 9K, 8K, 7K, like at the least, and it would take forever, and like we'd have to order the material, and then we'd have to get it to our machinist, and my machinist would have to probably complain. It's the big part. So then we tried it on Xometry, the international option, and then we saw $4,000, and we were like, wait, what? This isn't real. And they're like, yep, that's right. And
we could do it, and
yeah,
that's something
we're gonna do that.
That's something that you talk about, like Xometry. We have a distributed manufacturing platform, so we're connected to thousands of manufacturers. And one of these things, the basic economics is when you have a high supply, prices can go down, right? And that's what we're able to take advantage of, especially because we have both domestic. You're talking about, if we say international, we call it economy here. We're able to make that, and I think what's really, interesting. You're mentioning weapons here, and I know we're on a podcast. This is a giant slug of like almost like a rectangular O shape of metal that's spinning at super high velocity, like that could just, it reminds me of like the dangerous part of lathe work, right? Like just don't lean near it. And Ethan, I got a question for you, and I'm not trying to hijack the podcast, but
no, go for it.
There's lots of ways to destroy robots in Battlebots. Why'd you choose the spinning massive slab of doom as your weapon method?
Well, if it wasn't already obvious, it's really cool. No, but the actual reasons though. So there's a bunch of different weapon types in Battlebots. So there's grappler lifters, which aren't kinetic energy based weapons, but they're just like kind of control based weapons. And then there's the huge horizontal spinners like Tombstone and Bloodsport and robots like that are just like really high inertia, because they could kind of fit into like this flat profile horizontally really easily, so they could have this wide area. And then there's the vertical spinners who spin vertically. And so we knew vertical spinners tend to hit the hardest, which we kind of wanted, obviously.
Sure.
So when a horizontal hits someone, it's the law of equal. Newton's third law, something like that. Law of equal reactions, right? So if a horizontal hits someone, they deflect, right? Both of them go. A lot of the energy is lost in that hit. Both robots deflect and move. With a vertical spinner, though, it's different. If I go and I hit someone, the robot plants itself into the ground, right? And all the energy goes into the opponent, and I don't move. So I'm transferring way more energy than a horizontal spinner would, despite having a smaller weapon.
So your spinner spins like up, like underneath.
So when I hit someone, that plants me further into the ground. So I get way more traction. I don't move, and all the energy goes into them.
And you just send them flying.
Yeah. So yeah, that's the whole idea of a vertical spinner. So instead of needing an 100-pound bar to do major damage, I only need a 50-pound bar to do more damage.
Just 50 pounds of steel, just a casual 50-pound steel rotating at however many RPMs.
Yeah, 4140, 13-inch diameter, 14-inch long steel.
It's huge.
And it spins at 180 miles per hour plus. And it's just really, you don't want to be in the room with that. I tried that once, never again. It's really
terrifying.
Yeah.
So just putting some safety glasses on doesn't work.
Yeah. My dad and I were about to test. I was like, Dad, put safety glasses on. He's like, what would that do? And I'm like,
what is this saving me?
Just do it.
Other than put shards of plastic into my eyes when it hits me.
Right.
Yeah. Safety glass. If something actually went wrong, safety glasses wouldn't protect us, unfortunately.
I think that's fair. All right, so I'm really excited to keep going with this, but before we do, I think it's time for us to take a break for a word from our sponsor. And for that, I feel like, Greg, it's only right to tee this one up for you first.
Yeah, so today's episode is sponsored by Xometry. Xometry is a on-demand manufacturing marketplace, and I'm Greg Paulson talking about Xometry because I work here. What does Xometry do? As Ethan notes, we make parts on demand. We make it very, very easy to do so. You can actually upload your technical file, usually a 3D CAD model. We accept most major file formats, and you'll get pricing and lead times on over a dozen different manufacturing processes. That could be things like what we're mentioning here today, which is a bunch of CNC machining of plastics, metals, special alloys, turnkey finishes on those materials, sheet metal, injection molding. And on the 3D printing side, we have 8 different auto coating methods of 3D printing. 6 are polymer based, 2 are metal based. And the other thing to note is that we have unlimited capacity. We are a platform, one shop that you go to get parts. And we have a vetted network of over 5,000 suppliers globally that are able to do that work on demand in parallel, which can give us great prices and great lead times.
Awesome. Ethan, what about yourself? Any shout outs you want to give?
So adding on to Greg Paulson's, at Riptide, we call Xometry the Uber of manufacturing. Like they're kind of like, they connect us like with the supplier. So I don't know if that's relevant or not, but like, let's say machinists are the drivers and we're the passenger, and Xometry is the connector part. So Xometry makes everything go together, click successfully with thousands of networks around the country, around the world per se. And to be honest, being 20 years old, I don't have a lot and fresh out of high school. I don't have a lot of networking. I'm not, like I haven't been doing mechanical engineering for 30 years and I have, tens, like hundreds of machine shops that I know that I could just, say, hey, do this, hey, do that, like I just don't have that yet. So as a new engineer, Xometry has been super, super imperative in like getting really hard parts done cheaply and quickly. Because we don't need to know like who's good and who's not, like who's a good machinist and who's a bad machinist. We don't really know how to tell the difference. We're kind of learning that as we go now, because we haven't done this many manufactured parts before. So Xometry in that regard has been super, super imperative. I also want to mention our other sponsors. So we have Sencut Send, who has been really, really great to us and has been making beautiful laser cut parts. So thank you to them. Be Courageous, which has been inspiring us and helping us achieve our goals through just strategic planning and just motivation stuff. Maxamps has been making really, really great LiPo batteries for us, and they've been powering our weapon and our drive, and those have just been super powerful and super well made, and we're really grateful for that. And Rolling Robots, which is actually the program that taught us everything we know, is also sponsoring us. And they have great camps and teaching facilities that have really helped us get to the point that we are now.
Very cool. Luke, maybe someday we'll get to be a sponsor of a BattleBot. What do you think?
I think we could. I think we got to start making some money first.
That's the problem.
That's the
problem. Fair enough. All right. So Luke, I know you're burning with some questions here. What do you have for us?
So my biggest question is when you think about getting into BattleBots, like I want to go back just a little bit. You talked about when you were a kid. I'm always interested in like what got you into mechanical engineering, and we can come back to the robot and stuff like that. But like I know when I was a kid, I would just take things apart, and I would like VCRs and alarm clocks and like all those. You probably don't know what a VCR is
without your parents' permission, right? You're just like, what happened by VCR
all the time? and I'm just wondering, the reason why I get so excited whenever we get to talk to young folks, and then we get to talk like BattleBots. Like I think engineering, is something that all kids have a propensity to do, and then at some point they just like they either go one direction and they just choose not to do it, or they go the other and they end up in school for engineering and become an engineer. And I'm wondering what kind of triggered you as, I'll say, a younger person than you are now to get into engineering.
So it's weird because my story, like, I can't say like, oh, I like took stuff apart and like wanted to become an engineer like after that. Like that's like so not my story, which is really, really weird because I feel like I'm the only one like with a different story. So I feel kind of weird in that regard. But like as a kid, like, you know, 8, 9, I did a lot of like, you know, Mindstorm, like basic like Lego robotics. And to be honest, like I did not like the programming side. And like this camp that I went to was very, very programming based. And I did not like it. I did not want to go. So for a while there, I thought I really didn't want to become an engineer. I just didn't like it. I wanted to go home. I wanted to play Minecraft. I didn't want to go. So fast forward 3 years later, I was 14. I was kind of interested in like drones. I thought drones were super, super cool.
Which they are.
And then so like I was driving like these tiny little drones I bought off Amazon. I was like, and then at school, you know, it was like first year of high school. I was like talking to my engineering teacher. I was like, I want to start a drone racing club. And then my engineering teacher was like, that's dumb. Come join the robotics team.
Nice.
I was like, okay, sure, I'll see what's up. And then this is the VEX robotics program at the time. And you know, I just started, there was like a competition game. I thought it sounded all interesting. And then we had to build a robot for it. So I just started building. And originally it was 1 day a week. And then it became 2 days a week. It became 3 days a week. And 4, and then every day a week. It just was really, it started to progressively get more interesting. No one was pushing me into it. I like coming. And so I really wanted, and I loved it, and I really wanted to be good at it. So I just kept progressing towards more work. And eventually, I didn't want to play Minecraft anymore. I just stopped playing video games altogether. I just wanted to do this robotics stuff at school because it was just really, really fun. And so, you know, we just kept building and getting better. Eventually, I got kicked out of my school team because I tried to enter a competition that my teacher wouldn't let me go to. So I eventually got kicked out of my school team because I registered for this competition and wasn't supposed to go as an independent. I tried to do it in secret and I failed miserably.
Clearly.
And then, so then I kind of transitioned to this program that I mentioned, Rolling Robots, and they taught me like how to do things well. Like, whereas my teacher before wasn't really teaching me anything, he was just kind of watching. Despite being an engineering teacher, is doing the watch from afar, lazy teachers method instead of actually, you know, getting down dirty with us. But Rolling Robots had like a bunch of people, you know, getting down dirty with me, like teaching me like the right way to do things, like engineering wise, and like helping us really, really become a high performing team. Like we had potential before, but we wouldn't have become it without a good mentors. Like we wanted to work and we did work, but our robots sucked because we didn't have any guidance. So, you know, a few years of that, and then we in at senior year, we were kind of first in the nation for VEX robotics, like in terms of just like tournament, like we were feared, and like we would win every competition we went to almost, and you know that's how senior year kind of ended, and that's how I became I was becoming really competitive and really good because I knew these things and I worked really hard. So after that, you know, COVID kind of struck, and then BattleBots kind of came into mind because, well, originally I was going to do online schooling. I did online schooling for a little bit, and it was just really hard for me to focus. I'm quite, you know, I have ADD, and I'm quite an ADD guy. I can't focus on boring professor on Zoom for too long. I need to, you know, work in Fusion and like do things with my hands in order to really, really get it. And you know, like not like majoring in mechanical engineering, I needed to do hands-on things to learn. Like I wanted to do hands-on things to learn. Online schooling felt like I was doing like hard coding with no like other supplement to it, like I was when I was 10, all
Gotcha.
over again. Like I actually do like coding now because it's like supplements myself with robotics. So then after that, we decided, okay, now is the best time to do BattleBots. We need to find money. We're not that rich.
I feel like it
So-
teaches you a lot of different aspects as well,
Yeah.
though, like the engineering side,
Oh
the
my
coding side,
God.
the business
Well-
side. It's really amazing.
Yeah,
I
there's-
even think about the CAD, right?
Right?
I'm wondering when you started using CAD, and I know I'm middle of the age in this group here, I think, but I was a graduate 2002 of high school, and my junior year we had an introduction to drafting where we did all table work, like learning how to write everything at 1/8 inch and all that stuff,
Mhm.
and drawing in perspective, and then my senior year was when I could actually do CAD on, Autodesk mechanical desktop, and I did competitions for CAD. We didn't even have a robotics team at that time, so like yeah, now that CAD's just like a natural thing. But yeah, what year did you get introduced to making 3D modeling?
So I was introduced to Fusion 360 in 11th, 10th grade, as a student.
That's
And
so
we
cool.
That is.
I had a student
Yeah.
account back then. And at first it was the thing I was kind of forced to do because I didn't really see how it related to like Vex robotics at the time. So it was like, oh man, like what do I need this for? I'm not even really using 3D printers. But now I was like, thank God I was introduced to that. Like you cannot build a BattleBot without CAD. Don't try.
For sure. Yeah.
Yeah, it's
That's-
such a huge entry to all manufacturing now is CAD based, and I think some people who want to get into that don't realize it, and then it's like, what is your design? Like, what's in my head?
Right.
And that's
yeah. How do I make that?
there's a transition.
Yeah.
Yeah.
So I was gonna say,
BattleBots,
okay.
BattleBots are supposed to battle, right?
Yep.
And
Yes.
you have a big throwdown happening here in a week or two. I'm really curious. First off, what do you think your biggest advantage is? But also, kind of coming back to Xometry and the rules of BattleBots, what happens when your robot might take an injury and you need a little bit of replacements? Do you have extra parts? Are you allowed to apply them? Do you just order them through Xometry real fast and hope for the best?
Oh God. So we have 3 sets of spares. So here's our strategy. So we have 3 sets of spares for everything for sure. And we also have 4 sets of some parts that are like kind of on the outside that we expect to get abused a little bit more.
Okay.
So the thought is we have a bill of materials, like a list of how much materials we have in the quantity, and like what we have so much stuff, we had to figure out a way to organize and mentalize what and compartmentalize what we have. So the thought is, and how Xometry relates to this, is Xometry is letting us kind of take advantage of their nearby network of machinists, so we could get things really, really quick. So our strategy is we have 3 sets of spares, but if we see spares dropping like flies, we'll have a few days where we could still survive on X amount of spares that we have, and that we can order
That's smart.
extra parts expedited to BattleBots. So that's kind of our strategy, is we have enough spares to survive for a long time, and then use Xometry's expedite function to get things really, really, really fast on things that we are going through quite quickly, because we haven't fought before, so we have to take advantage of that. We don't know what's going to die as fast as fast as possible. There's so much we don't know, and Xometry helps basically bridge that gap.
For the just-in-time manufacturer, yeah.
Yeah.
So speaking of you haven't fought before, so like I'm envisioning you guys are building, this robot, right? And you're all excited and you're turning on and testing and the thing's whipping around, but you've never hit your robot with like a pickaxe or a flamethrower. You've never flipped it upside down, I'm guessing. So when you don't know how it's going to react to an attack, like you might think this weld is good enough, but maybe it isn't. How have you tackled those? Are you guys doing FEA? Are you doing physical testing? Like how are you like anticipating being able to take a blow from another robot?
So that's a good question. It's a combination of factors that we're factoring in. Like we built this robot on the 3-pound scale instead of the 250-pound scale, like 7 times, and we fought it a bunch of times. So we kind of got a lot of experience off of that and understanding basically how the 250-pound would act off of the 3-pound version. So we took the 3-pound version and scaled it up relatively. In terms of like how we know it'll break, we are using FEA on a lot of parts, which has been really, really helpful in reducing weight on like a lot of different components and having just the necessary weights and stuff. We, in terms of like seeing how things are going to break, and like you said, how do you know if this weld is thick enough or not? Well, it's a good thing we're not using welds, but in general, we also are able to watch other teams and they teach us like, this is how things break. We read on it. We do our best to study up on it, but in truth, that won't totally prepare us. Battlebots has a starting cost. It's hard to enter and it's hard to stay. So like we have been preparing as much and as best as we can, but you know, the first year we're gonna have to pay more. We're gonna have to get beat up in our first match to know like what's going to fail on the robot and learn the hard way. That's the starting cost of this whole thing. So we're seeing what's going to fail in what way in our first match and in the rest of the matches as well. So this first year is we're going to get the crap beaten out of us. It's not beaten out of us. And we're going to essentially learn from that how to get better as we go. You know, we have prediction models, FEA and Fusion, which has been really, really helpful in like getting weight off parts while still having a lot of structure. And that's also helped us like analyze how hits work with our weapon bar, like how would our bar bend or change if we hit someone, and how would that work? And that, you know, because we're kind of new to this whole engineering thing, like real engineering things, like not just like, you know, Vex, like put metal together and boom, it works.
Right.
You know, we're not too experienced in physics, so we need having simulations that are pretty simple and easy for us to see how materials would react has been really, really helpful to us and like understanding how things break in that way.
Awesome. So
yeah.
It sounds like when I stop in Vegas, obviously I'm putting some money on Riptide, but
Yeah.
who do you think would be maybe another favorite that I might want to, you know, throw a little money down on as well?
If you're putting in money, someone's gonna get mad at me if they watch this. If I say that.
Well, we don't need to answer. Riptide is the only team then. How about that?
Riptide's the only team, but I will say there are some really, really impressive teams out there. And there's three that I really, really love. So I'll tell you the three that those are. Or four, so I don't get yelled at.
Okay,
so the first one that comes to mind of someone you want to put your money on is there's two robots in this category. It's Bite Force and it's Endgame. This robot Bite Force has won the giant nut, which is the trophy. Like
obviously.
Like I don't even know, like 3 times, like a bunch of times. And they're good because they know how to win. Like their robot is so simple, way more simpler than Riptide. And they know like what they need on their robot and they only have that. They don't focus on anything else. And they're really and like if you kind of watch their pattern of how they perform, they tend to only really come and try really hard if they know they can win. So if they're there, you should be scared. Endgame is another robot that comes to my mind. Endgame's like compared to like Bite Force and Endgame in our way, very similar robots, but Endgame is on this other scale of like as complex as possible to be as great as possible. Bite Force is just really dirt simple. Endgame has 20 receivers inside their robot, all for redundancy. So they have two receivers for each ESC, each electronic speed controller. So, and they have like this whole system that if they lose an ESC, if they lose a receiver, then they can switch it out for a working receiver. Like it's absolutely like they have redundancy system on redundancy system.
That's so cool.
So that's Endgame's strength is like in terms of like connections and like they really think about their redundancy and like think about that. So that's like, and they won last year. So that's another robot you might want to put your money on. And then, you know, there's the guys who have been mentoring us. Actually cool. Cut that out. I'm not supposed to say anything about them.
Okay.
There's
get them.
Yeah. So on a separate note, in the cutout version is there's actually been a team that's mentoring us, and they don't want to know it. They don't want anyone to know they exist, so I just said their name. So oops.
All right, Luke, we're gonna edit that part out.
All right, thank you. So on a separate note, there's also been like some other guys that have also done Vex. Endgame has done Vex as well, and Bloodsport, another team has been doing Vex, and they've been helping us out as well and kind of teaching us what this is all about. And they have a really, really awesome overhead spinner that's really fast on its feet and really simple, kind of like Bite Force, but in like a horizontal form in terms of like redundancy and just how hard it hits. It's just a really cool robot. It's the only robot to beat Endgame last year, so that's how you know they're good. They didn't win the whole thing, but I just love their robot. I don't know, it was just so entertaining to like watch fight. It hit really hard. It was fun to watch zoom around the arena. Like Bloodsport is a robot to look out for, and we're friends with them, and they're just really awesome guys.
It's cool that the community seems to be kind of tight, though. Like, you don't hate each other because they might win. You respect the engineering and whatnot going into the other robots.
So here's the thing, right? So with Battlebots, we're not a sport like football and like an established sport, right? So, the builders know this. Like, we're only so big. So, with the collective goal of becoming bigger, you then realize new people that are brought into the sport need teaching, and we shouldn't hide things from them, and we shouldn't hide things from together. So collectively we could grow and make better matches, right? So that's kind of the mindset of the BattleBots community, is everyone collectively grows together. So like you come in, like, I've heard this happening all the time. Like you come in and then other teams just load you with advice, like good advice, and like teach you like the ropes of BattleBots essentially and how to build well. Which is like which was such an enticing factor of why to enter. Like, was because you got to learn from so many people so quickly at once. There's like, in terms of like experience and like learning how to do like engineering, I think I've progressed so fast just because like I've been put in such a like in such a fast progressing, dangerous setting that's also really supportive. So my skills have just gone like so much faster than they usually go. So that's like basically how the community works, is everyone is like, I think like Ray Billings from Tombstone once shared a story. He gave some guy his spare motors for a fight just so he could destroy the same spare motors essentially. Sorry, I'm gonna repeat that sentence because of the Alexa, if that's a good idea. So basically, Ray Billings told me this story, or on the internet, that he gave someone his spare motors to help them get working because they were like on their last legs right before a match that he went against them, and they fought him, and he destroyed his spare motors.
That's funny.
And it's all in the name of progressing and getting the sport to be bigger and better, because the sport's just like a really inspiring sport, inspiring engineers everywhere to become engineers. And it's really imperative and important that BattleBots gets bigger in order just to inspire more people and engineers. And just it's like the one sport it's a sport that'll just truly make this world like a better place, because by watching it, you get inspired to do engineering, and then you go and do engineering, and engineers are the people who make the world turn.
I love it.
So
that's great.
It's there's no excuse to not watch BattleBots.
That's right.
On Discovery Channel.
Luke, we're running out of time here. Is there anything else that you wanted to ask real quick?
So the only question I have, and you got to make it quick because we're low on time. What's the meaning behind Riptide?
Yeti has been this team who had been competing for years and years and years, 20 years. So as I was being born into this world, Yeti was like, let's go build a BattleBot. So they've been teaching us, the ropes, like truly, like they come down, their inner Zoom calls, like teaching us like how to CAD things better or how to make things better. Because like the idea of Yeti has always been like hardcore, simple reliability, right? Like they don't use CAD a ton, but they know how to build a robot that survives matches.
Mhm.
So whereas my approach was totally, and it worked perfectly with my approach, right? Because I needed someone who knew how things would break, and I needed someone to teach me that, because I knew by then, I knew, like, as I was applying to BattleBots, I knew how to CAD very well and how to make something look really good, and how to, build parts like from a general perspective, right? I didn't like no, but I knew a good idea. I had an idea of what was needed, but I need someone with experience. So Yeti was those guys to us. And why we're named Riptide is because we kind of wanted to be an homage to Yeti in a way, like in terms of like relating to water, and like we have a drum spinner similar to Yeti, like we've kind of, and lifters as well. We wanted to be like an homage to them.
That's cool.
So Riptide, water-based, aggressive water, basically is at one point a friend of ours basically just put a bunch of names out, like I don't know, she's really good at that. She just put out like a ton of like names that like warp speed, and then we just picked Riptide.
I love it.
So, and that's how aggressive water, that felt pretty perfect for us and what we were trying to accomplish, because we're aggressive with our weapon bar, and it's kind of like, a relaxing, ASMR, like video, ASMR, sorry, video. And I don't know, it's like kind of perfect for us. That's how it came to be.
Greg, any parting remarks for you?
It's just exciting to hear the story. For me, I just love the access to CAD, to programs like this from an early age. It's the progression is just fantastic. And this, to Ethan's point, these are gateways. Like, engineering sometimes doesn't feel like engineering. It's when you're following your passion, when you're following these hobbies, like the maker movement, you name it. Minecraft, even, it's a gateway drug for CAD.
Sure.
Don't tell anybody.
Gateway.
But it's
definitely addicting.
but yeah, it is just, it's just really exciting to see like what you could do, and you could actually go and create stuff and make real things. And that's my whole life is, making real stuff. So just excited to hear the story and be part of it in some way.
That's great. Well, Greg, thanks again for coming on with us. Ethan, it's great to have you here for the first time. I'm excited for you to come back on the show after you're coming back as the champion.
For sure. Yeah. Thank you for having me.
Giant nut in hand. Looking forward to seeing you on TV. Best of luck.
One day, for
That's
sure.
Right.
If not this time, another time.
If any of you have questions for Xometry, if you have questions for Ethan about Riptide or BattleBots, feel free to reach out to us directly at unprofessionalengineering@gmail.com, and we can get those questions over to them. And until next time,
see ya.